Okay, so today we're going to talk about the sum and difference identities for cosine. So I'm going to go ahead and give you these identities right away, and then I'll help you understand how to use them, when to use them, and why to use them. So there's sum identity for cosine. What I need you to see is that what we're doing is we are taking one angle, we're going to call it angle A, and we're going to add that to a different angle called angle B. So these are two totally separate angles, different angle measurements, different information. And how we handle that is if I am taking the cosine of angle A plus the cosine of angle B, this is equivalent to the cosine of what angle A is multiplied by the cosine of angle B, subtract the sine of angle A, multiplied by the sine of angle B. And again, what I want you to see is we're going to have two different pictures. We're going to have picture A and we're going to have picture B. So as a very quick example, what we would do if I have this picture, which we're going to call this picture A. So let's highlight that there in orange for my picture A. And let's say that this is a 30-degree angle. We know the side across from 30 is 1, the hypotenuse is 2, and the adjacent side is square root 3. And let's call picture B, let's draw a different picture. Let's say picture B is 120 degrees. So this is picture B. And I'm going to tell you that if this were 120 degrees, I would have a 60-degree reference angle. Across from 60 is square root 3, adjacent side is -1, hypotenuse is 2. So this would be the situation where I am saying, well, what is the cosine of 30 degrees plus 120? And we would be able to do the cosine of 30 times the cosine of 120, and I would subtract the sine of 30 times the sine of 120. Now some of you are saying, well, Mrs. Wager, 30 plus 120 is 150. Why would I do this? Well, sometimes if you look down on the bottom of the paper a little bit more, sometimes I don't give you angles that we know how to work with. Sometimes we have to take angles like 75 or -15 or even 105. Those are triangles we don't know any information about, but we can get information about their exact value by using values and using angles that we do know. So this is what we're talking about. We have two different angle measurements with two different pictures, and we can go from there. We know how to do cosine of 30. Cosine of 30 would be square root 3 over 2. Cosine of 120, I'm using picture B now, would be -1/2, minus sine of 30, which would be +1/2, and sine of 120, which would be square root 3 over 2. You would continue with this multiplication of fractions, multiply straight across, and then subtract your fractions because they will have common denominators. I'll show you some of those examples here in a moment. So jumping down, if we had to subtract two angles that we know the information on, again, I'm going to call angle A in my orange and angle B in my blue. This would be the cosine of angle A times the cosine of angle B plus sine of angle A times sine of angle B. Notice they look super similar to each other. That's because they are. The only difference that we have in between these identities is that we are subtracting my cosine multiplication and my sine multiplication. We're subtracting when you add angles, and you are going to go ahead when you are subtracting angles, we add. So we do the opposite operation. Okay, so keep that in mind. There's our two identities, so let's use them. As we look through this first example, example A, what we want to do is we want to find the cosine of 75 degrees. Well, we don't know the triangle side lengths of 75 degrees, but what we do know is that 75 degrees is 30 plus 45. We know those angles. In fact, I'm going to go back up to the top. Angles that we know. We know 0, we know 30, we know 45, we know 60, we know 90. We know 120, we know 135, we know 150, we know 180. So there's quadrant 1, quadrant 2. Quadrant 3. We know in quadrant 3, 210, we know 225, we know 240, we know 270. Quadrant 4, we know 300, we know 315, we know 330, and we know back to 0 of 360. Now those are in degrees. Keep in mind when we start to work with our radians, which you're going to see in example D, we need to know all of those radians all the way around also. So I'm going to go on the side here just to refresh our radians. We know our radians in quadrant 1 are going to be my pi over 6, my pi over 4, and my pi over 3. We also know that 90 degrees would be my pi over 2. My quadrant 2 would be my 2 pi over 3, my 3 pi over 4, and my 5 pi over 6. We also know that we have pi right there at 180. My quadrant 3 ones that I know, these are all my 30, 60, and 45 degree reference angles. I would have it 7 pi over 6, 5 pi over 4, and I would have 4 pi over 3. There's my 30, my 45, and my 60 degree reference angle. And then I'm back on the 270 or the negative y-axis. This would be 3 pi over 2. My quadrant 4, I would have my, I would be at 5 pi over 3. That's my 60 degree reference angle. I would be at 7 pi over 4. That's my 45 degree reference angle. And I would be at 11 pi over 6. And then back to either 2 pi, or we could call that 0. So we know all of those angle measurements, and we are going to have to work with some of those fractions. If the problem starts me in degrees, then it is okay to separate into degrees. If the problem starts in radians, make sure you're doing this in radians. So we are doing a sum identity for cosine. That means I'm doing 30 and 45. So I have the cosine of that first angle, which is 30, times the cosine of the second angle, which is 45, minus the sine of the first angle, 30, times the sine of my second angle, 45. We know how to find these. These are chapter 1 type of questions that we would have done. Let's draw our pictures. 30 degrees gives me 1, 2, square root 3. 45 degrees gives me 1, 1, square root 2. So cosine of 30 is root 3 over 2. Rationalized cosine of 45 is root 2 over 2. Minus sine of 30 is 1/2. And sine of 45 after we rationalize is root 2 over 2. When I multiply fractions, I multiply straight across. So I am multiplying here root 3 times root 2. That is going to become root 6. 2 radicals can be squished under 1. So just so you guys can see the work off to the side here, root 3 times root 2 is the same thing as 1 big square root of 3 times 2, which is where I get root 6 from, over the denominator of 4. 2 times 2 is 4. Minus square root 2 over 4. And we can finalize this by combining that numerator, root 6 minus root 2. These are not like terms, so they do not combine. We leave them separate, but I do see that we do have common denominators of 4, so we can leave our answer like that. If we are moving over into question B, negative 15 degrees. Negative 15 degrees, if I think about what I can do with this one, I can take 30 and subtract 45. 30 minus 45 is negative 15, so 30 minus 45 would be good. Those are angles that we know how to work with. So this is a subtraction of cosine. Zooming out in the notes, subtraction of cosine says cosine of A, which is 30 degrees, times the cosine of B, which is 45, plus the sine of A, which is sine of 30, times the sine of B, which is sine of 45. We already have these pictures drawn off to the left, my 30 and my 45, so I'm going to use those same triangles that you can see in example A. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. I'm adding on sine of 30, which was 1/2, and sine of 45, which is root 2 over 2. Again, we multiply fractions straight across. So root 3 times root 2 is root 6 over 4. And 1/2 times root 2 over 2 is root 2 over 4. When I combine those fractions, this is going to become root 6 plus root 2 all over 4. These don't look much different, but I am telling you subtracting square root 2 versus adding square root 2 are numerically different. So looking at something like question C to get 105, there's a few options that we could have. We could take cosine of 60 and 45. Now, something that I've seen in the past is I have students who do something like, well, I could do the cosine of 75 and 30. Well, guys, here's the deal. Do I know how to draw a triangle of 75 degrees? Do I know those side lengths? No, I don't. So this is not a great example. This is not something that I would suggest that you do. You always want to pick angles that we know the side lengths to. Don't use angles other than the ones that we know. So if I do cosine of 60 plus 45, I would have the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. We don't have a 60-degree triangle drawn, so let's go ahead and put that in there with a 60-degree reference angle. Cosine of 60 is 1/2. Cosine of 45 are root 2 over 2. Minus sine of 60 is square root 3 over 2. And sine of 45 is root 2 over 2. We multiply fractions straight across, so root 2 over 4 minus root 6 over 4. Combine like terms. And I get a final answer of square root 2 minus square root 6 all over 4. Now moving into a radian. We haven't seen one with radians yet. 7 pi over 12. Ugh, this one might make you panic a little bit. When we are in radians, what we need to remember with our radians is most of our fractions are our denominators are 6, 4, and 3. We don't have a 12. But what I do know is that based on common denominators, let's just kind of go off to the side. If I took 1/3 plus 1/4, my common denominator would be 12. So this is actually 4/3 4/12 plus 3/12 to get, look at that, 7/12. Some of you might be wondering if you can convert into degrees to give yourself a good idea. Sure, you can convert that. I believe 7 pi over 12, if we do that calculator work, remember how we do that in our calculator. We know that pi is 180. So I would take 180, I would divide it by 12, and I have 7 of those chunks. So that is 105 degrees. We also know that the way that we can convert that, 7 pi over 12, I would multiply through by 180 over pi. My pi's would cancel. But some of you might want to think about that as 105. But please know that what I would want to see in your work is, because it started in radians, I would want to see your work in radians. And off to the side, I have 7/12. Well, that's 1/3 and 1/4. So I'm going to just change that to a pi over 3 plus a pi over 4. Now I know I'm working with a 60 degree and a 45, and the rest we can see in that problem prior to. I'm going to jump down into F. F is actually already written as our difference or sum identity for cosine. First thing I notice is that this is a minus. So that tells me that I'm actually doing the cosine of two angles that are being added together. Remember, the signs are opposite. And what we can clearly see is what my two angles are. One's 40 and one is 50, which essentially is the cosine of 90. What I would want to see, though, is I would want to see you identify what two angles we are adding together. Now, something like G. G has an angle in it, and it has a variable in it. We're going to do this with the exact same idea that we did before. This is the difference identity for cosine. So I have cosine of the first times cosine of the second plus sine of the first times sine of the second. Now the angle that we're working with is 0. Well, that is definitely one that we know, we should know. We know at 0 degrees, sine of 0 is 0, cosine of 0 is 1, and tangent of 0 is 0. So let's do the substitution that I know that I can do. What is the cosine of 0? It is 1. And I am multiplying that by the cosine of theta. 1 times anything is that whatever you're multiplying by, so that simplifies down to be cosine of theta. I am adding on the sine of 0. Well, the sine of 0 is 0, and I'm multiplying that through by sine of theta. 0 times anything is 0, so this would simplify into just being cosine of theta. It's okay that we leave a variable in the answer because we started with a variable. If I do, I'm going to jump down into an adding, so go to I. If I do an adding, I would have the cosine of 180 times the cosine of theta minus the sine of 180 times the sine of theta. Well, we know those values also. So I'm going to start to do my substitution. The cosine of 180 has a value of -1. That's being multiplied through by the cosine of theta. We are subtracting. The sine of 180 has a value of 0. And I'm multiplying through by the sine of theta. 0 times anything is always 0. So this final answer would be negative times the cosine of theta. Now jumping into example number 2. what I give you are two different information pieces. I am also telling you, though, if you look at it, I'm telling you what quadrants that both of those angles, in this case, we're talking about angle S. There's some information about angle S and some information about angle T. The problem tells me that both of them are drawn in quadrant 2. So I'm going to draw them out. Here is angle S information. Angle S says cosine is -1/5. Well, cosine is adjacent over hypotenuse. We've reviewed this a little bit. In order to solve for that last remaining side, we would do Pythagorean theorem. I would get y squared equals 24. Take the square root of it. That is y equals plus or minus square root 24. When I break that down, that is the square root of 4 times the square root of 6. So plus or minus 2 square root 6. So what we need to do is we need to look at the fact that this is going up. So I know that this would be 2 square root 6. There's my angle S picture. My angle T picture says it's also in quadrant 2, and it told me sine, which was opposite over hypotenuse. Again, to find that third side, most of you probably know this triangle by now. This would be a -4. If you don't know it, that's okay. Use Pythagorean theorem. So the question wants us to find the cosine of S plus t and the cosine of S minus t. Well, if we go back up into my identities, the only thing different about a plus or minus is that center sign. So it's not that much more work. We're just adding sometimes and other times subtracting. So in this example, what I would set up is I would have the cosine of angle S times the cosine of angle T. I am doing S plus T first, so I'm going to subtract the sine of angle S and the sine of angle T. Well, anytime I'm working with picture S, I'm going to look at the blue picture. Anytime I'm looking at angle T, I'm going to look at the pink one. So the cosine of angle S was -1/5. The cosine of angle T is -4/5. We are subtracting. The sine of angle S is 2 square root 6 over 5. And the sine of angle T is 3/5. I'm going to multiply those fractions. This is going to get me 4 over 25 minus 6 root 6 over 25. And those are not like terms, so I cannot combine that numerator, but I can put them over that common denominator. Now to do the cosine of S minus t, remember I showed you that the only real difference, this would be the cosine of S plus t. The only real difference when we do the cosine of S minus t is that center sign. So this would end up being 4 plus 6 root 6 over 25. Now the biggest difference in problem A versus problem B is here I'm giving you two different quadrants. I'm telling you S is in quadrant 1 and T is in quadrant 3. So make sure that you draw your pictures in the correct quadrants so that way you have your correct positives and negatives. They gave me information about angle S. Angle S had a sine of opposite over hypotenuse, 3/5. We would have to do Pythagorean theorem in order to find that remaining side, which would be +4. They gave me information about angle T, which is in quadrant 3, again an opposite over hypotenuse. Doing Pythagorean theorem, I'd have x equals plus or minus 5. Well, looking at the direction of this, it would need to be negative 5. So this is my S picture. This is my T picture. And they want me to do the cosine of S plus T, which would be the cosine of S times the cosine of T minus the sine of S times the sine of T. Any S picture, I'm looking at blue. Any T picture, I'm looking at pink. The cosine of S is 4/5. The cosine of T is negative 5 over 13. Minus the sine of S is 3/5. The sine of T is negative 12 over 13. Multiplying that, I have negative 20 over 65 plus 36, double negative over there, that's why it's a plus, 36 over 65, to get a combination here of 16 over 65. Now again, when I bounce over to the cosine of S minus T, this would be negative 20 over 65 minus 36 over 65. That center sign changes, so I would get a negative 56 over 65 would be my cosine of S minus T, where that first answer was the cosine of S plus T. This link will be posted in YouTube, and I will post that link in Schoology also. So some of you who felt like you couldn't keep up with notes, this was a little bit fast, please know that you can feel free to watch them as much as you need to. Your homework is section 5.3 in your packet, so it says homework 5.3, and please refer back to the notes if you guys have any questions. Have a great day.